In section 7 of chapter 5, we're going to be doing another set of polynomial division problems. This time we're going to be utilizing a different approach. The last lesson we did polynomial long division. Now we're going to do a shorter method called polynomial synthetic division. This technique is really, really good, but it has some major limitations that we're going to go over. Here's how I'm going to start this lesson off. I am going to do the same problem twice. I'm going to use long division first, and then I'm going to use synthetic division so that hopefully you can see a connection between the two topics and the two ideas. And I will also discuss about the limitations of synthetic division. So first, if I have that long red polynomial divided by the blue polynomial, I would set it up the following way. X plus 1 divided into 3x to the fourth minus 5x cubed plus x squared plus 4x minus 1. I'm going to go through this relatively quickly because this is something that we just got done doing. I asked myself, what do I need to multiply x by to turn it into a 3x to the fourth? The answer is 3x cubed. That'll give me 3x to the fourth plus 3x cubed. I'm going to subtract that. These will eliminate, and I will get negative 8x cubed, and I bring down the plus x squared. Then I ask myself, what do I need to multiply x by in order to make it a negative 8x cubed? The answer is negative 8x squared. Negative 8x squared times x is negative 8x cubed. Negative 8x squared times 1 is minus 8x squared. Take that quantity, subtract, these eliminate, and you're left with a positive 9x squared. And then I bring down the next term, which is a positive 4x. I repeat the process again. I ask myself what I need to multiply x by in order to turn it into a 9x squared. The answer is a positive 9x. 9x times x is 9x squared. 9x times positive 1 is positive 9x. Take that quantity, subtract it. These terms eliminate, as they always should. And then I have a 4x minus 9x, which is negative 5x. And we're almost done. Just got to bring down that negative 1 and then repeat this process one final time. Asking myself, what do I have to multiply x by in order to turn it into a negative 5x? The answer is negative 5. Multiply the negative 5 times the x and the positive 1, which I have in blue. You'll get negative 5x minus 5. We subtract that, and we're left with a remainder of negative 1 minus negative 5 is negative 1 plus 5, which is positive 4. That's my remainder, which is why my answer is the entire numerator, the entire top part, plus the remainder over the divisor. So there's my answer. Not an elegant solution, but it works. Once you get used to multiplication and addition and negative numbers, it becomes relatively straightforward. The technique I'm about to show you is blisteringly fast by comparison, but there are some caveats to it. There are some limitations. There's only specific times you can use it. You can only use synthetic division if what you're dividing by is a binomial. So there can only be two parts. You can't have an x squared plus 5x minus 3. You can only have two parts. Second, the x has to be to the first power, and it cannot have a number in front of it. You cannot divide by 2x plus 1 using synthetic division. You can't divide by 5x minus 6 with synthetic division. There's kind of a way to do it, which you'll learn in pre-calculus, but we're not going to do it now. We're just going to focus on linear divisors with no leading coefficient. Here's how you go about doing this. Now, this first step you could probably do in your head, but I want to write it out. You set your divisor equal to 0, and you solve. Subtract 1 from both sides. X equals negative 1. That number you're going to put in a little box. To the right of that box, we are going to write all of the coefficients in what we are going to divide into. So I'm going to do the 3, negative 5, 1, 4, and negative 1. 3, negative 5, positive 1x squared, positive 4x, and negative 1 at the very, very end. I'm going to draw a black line. I'm going to leave enough room for another row of numbers that are going to show up here. But I'm going to put a little line right here. And now we've set up the algorithm to start doing synthetic division. Here are the two rules. Any number below the line, you're going to multiply by the number in the box, and you're going to write that product above it and to the right. If there are two numbers stacked on top of each other on top of the line, we just add them together. And that's the number that goes underneath. So, first number goes straight down. Here's 3. I'm going to take that 3 and multiply it by -1. 3 times -1 is -3. Now I have two numbers, the -5 and -3, that are up top of the line. I'm going to add them together, get -8. Now I have a number below the line. Multiply it by -1, I'll get +8. Take the 1 and 8, since they're above the line, and add them together, you get 9. Since the 9 is below the line, 9 times -1, -9. 4 and -9 add together to get -5. -1 times 5 is +5. -1 and 5 combine together to get +4. If you look at the string of numbers that I just generated, and then look at the solution to the problem, you might notice some commonalities. These are the coefficients of each of these terms. The way we generate our answer is if the original problem's leading power was x to the 4th power, we are going to start one smaller than it, x to the 3rd power. And then we take these numbers and plop them in front. 3x to the 3rd minus 8x squared plus 9x minus 5 plus the remainder over what we were dividing by. And I'm done. Problem 1 has nothing really special going on. I just want to show it one more time. I have the red equation that I'm dividing by the blue equation, x minus 3. That blue equation will be equal to 0 when x is equal to 3. So that's the number that goes in the box. And then it's going to be a 2x cubed, a negative 7x squared, a positive 8x, and a negative 7. There is no number underneath the 2, so I bring that straight down. 2 times 3 is 6. Negative 7 plus 6 is -1. 3 times -1 is -3. 8 and -3 add together to get 5. 5 times 3 is 15. Negative 7 and 15 combine to get me an 8. This is going to be my remainder, so I'm going to circle it. Since my problem started with an x to the 3rd power, my answer is going to be an x to the 2nd power. Then I just take this number, plop it in front. 2x to the 2nd minus 1x to the 1st plus 5 plus my remainder over my divisor. A problem that used to take me several minutes, if not 10 minutes to do, now takes me under a minute to do. Problem number 2, I have the quantity x to the 5th plus 4x divided by the quantity x plus 2 quantity. That purple part is going to be equal to 0 when I have a -2. This is kind of a repeat of what I did with long division, but I want to repeat it still because it is a lot easier to not catch on synthetic division. Long division, if you don't put placeholders, you'll catch it. You'll find two terms that don't add together. You'll get you'll hit like a 5x squared and like a 2x that don't subtract with each other, so not like terms. You will not be able to catch it on here if you don't pay attention. I start off with a 1x to the 5th. My next number should be the number next to the x to the 4th. There is no x to the 4th, so I put a 0. Then there is no x to the 3rd. There is no x squared. There is an x, but there is no constant. Here is how you can check this to make sure you have the proper number of placeholders. Look at the highest power of x. It's 5. That means there should be an x to the 5th power, 4th power, 3rd power, 2nd power, 1st power, and a constant with no x's. So the way you can interpret that is, if this is to the 5th power, there should be 5 terms and 1 additional one. So whatever power this is, add 1 to it. That's how many numbers should be in the list. If it's to the 3rd power, there should be 1, 2, 3, 4 terms. fifth power, there should be 1, 2, 3, 4, 5, 6 terms. It's really helpful when you're trying to find the number of placeholders. All right, now, draw my line. Let's just get to adding and multiplying. This number has nothing to add to, so it goes straight down. 1 times the negative 2 in the purple box is negative 2. 0 plus negative 2 is negative 2. Negative 2 times the negative 2 in the purple box is positive 4. The green 0 and the black 4 combined together through addition to get me 4. 4 times negative 2 is negative 8. Negative 8. Positive 16. Forward 16 combined to get me 20. Negative 2 times 20 is negative 40. That gives me negative 40. There's my remainder. So the answer is going to start with 1 less power than x to the 5th. So it's going to start with x to the 4th. You could put the 1 in front of it, but it's not going to do anything. 1x to the 4th is the same thing as x to the 4th. Then it'll be minus 2x cubed plus 4x squared minus 8x plus 20 plus the remainder over the divisor. And that is my solution.